Then there's a function that normalizes this into a probability distribution. It's called Softmax, and we'll talk more about it in just a second. But before that, it might seem a little bit weird to only use this last embedding to make a prediction, when after all, in that last step, there are thousands of other vectors in the layer just sitting there with their own context-rich meanings. This has to do with the fact that in the training process, it turns out to be much more efficient if you use each one of those vectors in the final layer to simultaneously make a prediction for what would come immediately after it. There's a lot more to be said about training later on, but I just want to call that out right now. This matrix is called the Unembedding matrix, and we give it the label WU. Again, like all the weight matrices we see, its entries begin at random, but they are learned during the training process. Keeping score on our total parameter count, this unembedding matrix has one row for each word in the vocabulary, and each row has the same number of elements as the embedding dimension. It's very similar to the embedding matrix, just with the order swapped, so it adds another 617 million parameters to the network, meaning our count so far is a little over 1 billion. A small, but not wholly insignificant fraction of the that we'll end up with in total.